Hey, this is Jitesh. I'm a ex-data engineer for Amazon. I also used to work as a data architect for AWS. Today, Rob would be interviewing me, who actually founded a company called Remote. Rob, can you introduce yourself?
Yeah, of course. So my background's data science, machine learning, and software engineering. I worked as a engineering manager for a while, and I started a company called Remote.dev. And what we do is we connect remote engineers from North America and South America with startup companies in the United States. And so happy to be here with Jitesh asking this question. Let's say you work for an e-commerce company. Vendors can send products to the company's warehouse, which are then listed on the website. Users can order any product currently available in the warehouse and return the product for a refund if they are not happy. The front end of the website includes a vendor portal that provides data on sales in daily, weekly, monthly, quarterly, and yearly intervals. What kind of end-to-end architecture would you design for this company? What are the significant factors you need to consider when designing a data warehouse solution, both ETL and reporting, for a company like this were to expand worldwide?
Okay, thank you for the question. What kind of volume of sales are we talking about in this scenario?
Let's say why don't we just do 2,000 or 10,000 orders per day?
The question says user can order any product available in the warehouse. That okay. That essentially means you should also know what's the inventory. But let's get to that later. The front end of the website includes a vendor portal where they're looking for some aggregates, right? Or at
Mhm.
different granularities. So let's talk about this vendor portal. So say I am a vendor, I log in into the portal and or do we have a sense of how many vendors are we talking about?
Let's say there's 10,000 vendors.
Okay.
This isn't really important, but let's say the distribution is like some type of power law distribution where one vendor does a large majority of all the sales, and then there's the second vendor does half as much, the third vendor does
Yep.
half as much of the second vendor, and then there's some that don't sell anything, long
Yeah.
tail kind of thing.
Yeah. We can say that 5% of the vendors produce 80% of the sales. Is that what you're trying to say?
Yeah, something like that.
Okay. And that's the reality of most of the things, right? Okay. And say when they log into the website and this portal, whatever it is, what kind of performance do we want? Like, is it like when they log in, should we show them the most up-to-date data, like real time? Or is it like we refresh it once a day and we just show them, aggregate, but not real time, like a day behind?
So I got to think about maybe what the purpose is of this and like what the actions would be that a vendor would take after reading this data. So let's say I'm a vendor and I go into the platform and I want to see what happened yesterday. So let's say that yesterday we had 30 orders and the day before we
Mhm,
had 40 orders. Then
mhm.
I could maybe investigate to see what was the reason why we're having 25% less orders. When it comes to returns, now, I don't think this vendor table will be used to make any action on a specific return, for instance. Like they would look at that
Correct.
and say, "Oh, look, there's been this many returns. We have work to do." No, this is not.
Yeah.
This is kind of a reflection dashboard. And then also, I see it as being, 4 times a year they go in to look at what the quarterly report's going to be, and maybe in the future, another follow up to this would be some type of forecasting or something like we anticipate, because usually when you go to quarterly meetings, you usually do them when the quarter ends.
Uh-huh.
So yeah, I see this as kind of keeping track of how the business is doing and how healthy the business is. So that's kind of what I think the use would be. So I'm
Okay.
thinking that this is not going to be something that's going to have to be real time, because I can't imagine a vendor coming in looking at these statistics every couple hours to see whether it's changed or not, because that's really not going to change what they do day to day. They might look at it once a day.
Okay. Okay. Cool. That makes sense. So I put a header. How do we enable ideally it should be called what features to enable on the vendor portal. This could be from a latency standpoint, we are saying the data get lag like a day behind, right? Maybe in the future we can just improve that and it could be hours behind also. It would just be extra cost. That's it. Nothing. So this is how I'm setting this question up or setting the answer up, which is these is essentially my functional requirements, right? These things are my like data could lag a day behind is like a non-functional requirement for me. These are the things like 10,000 orders, retention, return window. These facts we'll use in the design which we make, right? So these could be as constraints, right? This is what we are after, and this is the latency or SLA or non-functional requirement which you're trying to meet. Any questions so far, or does this make sense?
Oh, sounds good.
Okay. Okay. So let's see. Can I assume the data is powered by Kafka or like any broker like Kinesis, something like that?
Well, you could use any tools you'd like.
Okay. So let's say our core data comes from Kafka, and what we are trying to do is trying to build like a data warehousing kind of a solution or like a data lake kind of a solution. I'm just being more flexible here. And what we are trying to do is, I think this is a easy star schema problem. So we could design like a star schema. So that's what we can do. So let's say we have a fact table, and let's call it fact sales. Then I see vendor, I see customer or user here, and then obviously they order products. Clearly, we have three dimension table sitting there already. So we're just going to we are going to have three dimension tables, and everything is going to connect to a fact table. So let's say this is dim underscore customer. Then we're going to have a dim underscore vendor, and then we're going to have a dim underscore product. So that's the goal. That's what we are trying to populate. Okay.
I think we could probably ignore is it in the warehouse or not in the warehouse, unless you would like to address it.
No, we can ignore it. We can build a generic solution. We can design a data lake or a delta lake solution also. So I'll keep it generic. Data warehouse as such doesn't matter, but we are trying to enable analytics. However, we do that up to us. Idea is to meet the function requirement and the non-function requirement, right? Right? Data warehouse or data lake is just a tool. Okay, cool. So this is our goal. This is what we are trying to populate. This is where we are. We are assuming data is coming from in Kafka. Why Kafka? You can replace it with any other message broker. It could be Kinesis. It could be something else. Okay. And after that, once we have messages in Kafka, and Kafka is essentially expensive also, right? So you want have a reasonable attention policy, which we said 14 days. So what we should do ideally is that we should land the data 1:1. Okay, so let's say we have a table called LND underscore events or landing underscore events. And we are going to read the Kafka data and dump it 1:1 in the events table without any transformation. That is, even if Kafka dies tomorrow, the Kafka broker breaks, the message gets deleted, we can always recover because we'll have a 1:1 dump inside the LND underscore events table. Does that make sense? Or what do you think on that?
Yeah, that's a good idea. It's a good way to save costs. Perhaps we might not even need 2 weeks of retention in Kafka. And if in the future something breaks and we have to replay, we can use the LND events table instead of Kafka.
Yeah.
Is that right?
That's exactly what we're trying to serve. And I'm going to use Spark streaming to actually get data from Kafka into this table. And I'm going to design this table in the lakehouse paradigm. So I'll use Delta Lake. I'll read this data using Spark streaming and write it as a Delta table. Why Delta table?
What is a Delta table? Can you define that?
Oh, yeah, sure. So basically, Delta is a storage format. Okay. The benefit of using Delta as a storage format is that it's ACID compliant. So it's atomicity, consistency, isolation, durability on S3 or on an object store. So basically, it allows you to do updates, deletes, selects, merges, stuff like that. And you don't have to physically do it on a database. You can still do it on, you can do the update and write data back onto S3, and that way you don't have to specifically write into a data warehouse per se, because now you can do whatever you wanted in an ACID format, which you couldn't do with Parquet or JSON or any other formats per se. That makes sense. I can give you more detail. What Delta table is, it's Parquet files plus a JSON transaction log. Both those things come together, and then we call it Delta. That's the storage format.
Okay, thank you.
Okay. Yeah, I'll write that because not a lot of people are aware of this. Yeah, now you can do ACID transactions on a data lake or lakehouse. So Does that make sense so far?
Yeah, and then can we store other things in the L&D events? Like if we wanted to add a particular, well, this would have to go through Kafka. But let's say we recorded the event and there's some extra information that's tagged onto it. We can also store that in the Delta store, correct?
Correct. So whatever we'll see in Kafka, we'll just store it as it is. Any other transformation which you want to do, preferred strategy would be create another delta table and do it there.
Okay.
That way, if there is the reason to do that is if you write some bad code, right, or if you write some bad transformation, then we know that your problem is isolated, right, and you can always replay from this table. So that is why you want to do a 1:1, so that
Mm-hmm.
no custom code breaks this job, and it's protected, right?
Mm-hmm.
So that's why we are doing this. Yeah. So any transformations you can happily do it, but do it like in the next step. It makes sense?
Yeah, makes total sense. So I see you're
Okay.
doing another Spark streaming job here, or is
Yeah,
this a
let's do.
batch?
No, we can do. So Spark streaming job can actually run in batch mode. So Spark streaming jobs have a mode called trigger once. So and there's also a mode called available now. So what you can do is you can have a Spark streaming job and you can use this mode called available now or trigger once. That way, what these both do, I'm hiding some, for simplicity, hiding some small knobs as such.
Mm-hmm.
But what these enable you to do is you are able to run your job with whatever data is available. And once it, finishes processing that, it stops rather than continuously running. So it's still streaming, your code is still streaming, but you have the choice of not having it to run all the time. Okay. So let's say we have this. Now, one thing is, would this events table have all of this information like customer, vendor, product, fact, sales, or what
Mm.
should we do here? Or are there different topics which just give customer, vendor, product information?
It's a good question. Let's say it
Right?
has as much context as possible. So let's say how it would get on Kafka is there'd be an event that would happen in the store, and they'd call an endpoint probably, and then there'd be some type of app node that would take the information about the sale or the event rather, and it would package it in some type of JSON format, and then it would send it to Kafka, and then
Mm-hmm.
all we're doing is kind of pushing it through the pipeline. So
Got
let's
it.
say it does contain customer, product, and vendor.
Yeah. Okay. So
Um,
let's assume there is a topic, like there are different topics, right? And that way, each topic can go to its equivalent table. Obviously, the transactional side of the system would also have, some kind of a customer or a product or a vendor table. It would be denormalized, but some version of it would exist. What we can say is that we'll have streaming jobs for each of these, right, tables. So we'll read a topic. Sorry, we'll read a bunch of topics. I'll explain why I'm saying bunch, but we can read like 3 topics on a single cluster and then route data to the applicable delta table. Why am I saying put 3 on a single cluster is because how many new vendors, customers, and products would be there, right? Not many, right? Or there would be
mm,
very few changes. So to utilize the cluster better, we can put 3 streaming jobs on a single cluster, and that way, we can get better resource utilization. I think for the I think in the fact sales, it's 10,000 a day. So I think if it's 10,000 a day, you can even put this job also on the same cluster. But if you get to like 1 million records a minute, or say 1 million records an hour, where 99% of the data of fact sales, when messages come onto Kafka, and if you have a distribution where 99% of the events are something with to do with sales, and worst percent is the rest, at that point, you should give a dedicated cluster to the fact sales tables, because else it would hog other resources, right? So that's
mm.
that's how you should think about it. 10,000 with such a less volume, you can put as many as many things as you want on that on a single cluster. But from a design perspective, if you scale too much, you should have a cluster dedicated uh, dedicated to topic which has the most amount of messages, so that it doesn't so that other tables don't suffer in latency because you have a cluster which just hogged all the topics, or you have a topic which just hogged all of the other topics. Am I making sense so far?
Yeah. So you're saying that a particular, let's say a particular vendor is
Not a particular one vendor. I was trying to say is like when there are vendor related events which need to go to dem vendor, and then there would be customer
Mhm.
related events which will go to dem customer. There would be product related events which will go to dem product. Now all of this by nature wouldn't produce a lot of data, right? Because
Mhm.
how many updates do we expect? We expect a lot of sales, right? So that is why I was saying that if you get to a volume where your sales is like 99% of the events, that
Mhm.
means you should treat the event sales topic separately and give it its own cluster so that
I see.
these small streams do not compete for the same resources as the sales topic.
So yeah, it sounds like so with this customer
Mhm.
product. So in this case, the question, I don't remember exactly what the question was. So it says vendors can send products to customers' warehouse, and it says users can order any product. And the front end website includes a vendor portal that provides data on sales on daily, weekly, monthly, yearly. Okay, so the question didn't specify this, but it looks like you've done this. So this is like where now you have the opportunity with these different tables, vendor, customer, product, that for a particular vendor, they can see how many products were sold to a particular customer, for instance, or just generally looking at the vendor, you can deduce how many products are sold for that vendor. And then you could also look at for that vendor, what are the different products and how much did they sell with for each product.
Uh, yes, but I don't think so. We'll expose that data to the vendor portal, because it would, like, when you join these tables, right, it would take a lot of time for the data to
Mm-hmm.
be produced. So ideally, what we'll have to do next
That's
is
true.
actually
Yeah.
create like an aggregate table which would join all of these, or let's say for vendor portal, we just need we don't need product analysis. We said return analysis, so maybe we need the product as well. So we need to join these three and create like an aggregate table. And this aggregate table, let me go back to your question. One is we need to serve it. We needed to serve it at a vendor level. So let's do a few things. Okay, so this is going to be an aggregate table. One is that.
Mm-hmm.
Now let's see. We are going to serve it to a vendor, so we can definitely partition this table on vendor ID, right? Because you want the query directly to go to that particular vendor. And then
Mm-hmm.
let's say, let's do something more, which is we have this different granularity, daily, weekly, monthly, and quarterly, right?
I just was thinking about, well, I mean, the question, the way it is, like we can kind of define what like extra things or take things away. What do we need customer? Like, because if we're
Technically,
just
there's
doing,
nothing. Yeah, there's nothing on the question. Like when we look at this requirements for the vendor portal,
I mean, it
right?
would be nice to have in the
But it's
future.
not
Yeah.
correct. It's not necessary. So you can easily, keep it, remove it. It just kept
Yeah.
it. Okay. Now trying
Okay.
to build this aggregate table for vendor. This is the table which will power the vendor portal. So all queries should just come to this table, and ideally you want the smallest query possible so that it returns the fastest. You don't want this table to be too big, else your query would spend a lot of time scanning, right? So let me think. So you have this unique key. I'm trying to think of a good column name, but can't think of any. Help me out here.
For the
So
aggregate,
yeah, so basically one would be I want a column which will literally store daily, like literally the
mhm,
value daily and literally the
mhm.
value monthly and literally the value quarterly. So that's what I'm trying to do. Time window, time grain. What should I call it?
Well, we also have to have a date, right? So yeah,
So
we can call it time grain. That's okay.
we can. So you're
Or
thinking
maybe
about snapshot
granularity
date.
or something.
Yeah, we can, going back to the hint which you gave me, which is you also need a date. So we can have a snapshot date. Snapshot date would represent when those numbers were produced, and then we'll have a
Right.
column which will represent this thing which I'm talking about, like daily, monthly. So every day we'll produce this numbers. That date would show up under snapshot date column, and then we'll have this time grain column which will have, stuff like this. And now I would say let's also partition this table on snapshot day and vendor ID. So every
Mhm.
day when people come on the portal, as long as they hit these two columns, which they would, which is, they will know the vendor ID and will know today's date, right? So
Mhm.
then that query can hit the partition directly, and there would be like 5 or 6 rows against this time interval. I think we should call it time interval. That's what it is anyway,
Yeah,
right?
that's probably better.
Yeah. So let's
So
let's
let's say
call it
they have a
time.
query with a snapshot date, vendor ID. It would come
Uh-huh.
back with
Five, 6 rows.
a lot of rows with maybe daily, and then maybe a couple with monthly. Depends on how long they've been on the platform, right?
No, when they would only see, like, say, monthly, quarterly, daily, weekly, month. So ideally they should only get 5 rows back, because the
And what would those
unique.
5 rows be?
So one would be their metrics for daily, one would be the metrics for monthly, one would be for quarterly, one would be for yearly, one would be for weekly. Am I making
Wouldn't
sense?
it be 5 rows back? Oh, I see. Wouldn't they want to see kind of like if it was daily? Wouldn't they want to see? Let's see. This is a good question. How about this? What if they provided a range and they said, okay, October 1st to October 31st, show
Hmm.
me the statistics, and that this query would return all of the daily numbers, and they can look at it and see, okay, you sold 10 things on October 1st. The next day you sold 15 things. And
Yeah.
then it would have one statistic for the monthly, which would be the total. Let's say it's 300. And then the quarterly would be not even calculated yet because it's only been a month. Let's say they've only been a vendor since October 1st. What do you
Got
think
it.
about
So
that?
yeah, you can still, you're thinking like a chart, right? So basically you just want to see, say, last 15 days worth of your daily sales, right? Something like
I
that.
might be
Is that?
changing the question. I apologize if I'm doing that.
No, no, go ahead, go ahead.
Yeah,
No,
so
no.
it was, were you thinking just showing for that day, kind of like this is how many that day, the day before?
Yeah,
That's
that's what
okay
I
too.
was.
We can do that too. Yeah.
But to answer your question, even this
This is more of
query,
a
which
kind of a follow up that I'm talking about, I suppose.
no, no, it makes sense. It anyway solves it. This table would still would still give you the data quite quickly, right? Because it's aggregated so much, and you're going to hit a partition anyway, right? So as long as the query is, as long as the query even snaps hits the right partition, you'll get results quickly. So it won't take long. So basically, even if,
Mhm.
say, someone gives a range, right? So the query which will be sent to the backend would be, hey, where snapshot date between, right? And there would be two dates, right? So date one and date two. And so it's hitting the
Oh,
partition.
I
So
see. I
even
see. So you don't have to
same,
change what you were saying earlier. All you would have to do is give it a different query and it would still return what you're
correct.
saying
And
here.
yeah,
Okay.
still would return reasonably fast, because we'll be hitting the partitions. And the data is anyways not much, right? Even if it's like,
Yeah.
how many vendors would you have? Even if you have 1 million vendors and you're so successful, right? Then also you are going to hit, the query is going for a particular vendor for a particular date.
Mhm.
But yeah,
Right.
this should.
So for 30 days, every vendor, no matter how big they are, would only have like 31 integers or something. Is that,
Could you
or let's
repeat that?
say that for any vendor, no
Yeah,
matter how many sales they have or returns or anything, how much data they have, they would only
yeah.
get this much data. It would be the number of days in a month plus one. And if they had yearly or quarterly, it would give maybe two extra pieces of data. Is that correct? Maybe that's not
Uh,
correct.
you understood more right than wrong, I would say. There's still confusion on the granularity, but
Mhm.
every day for a snapshot, for every day per vendor, you're going to only have 5 rows, right?
Mhm.
Because that time interval has only 5 unique values. So even if
But
your
what if it's through
query,
multiple years though, or multiple? Let's say it's 2 years worth of data.
so even if you're
What would?
querying 2 year, yeah, even if you're querying 2 years worth of data, right? And
Mhm.
say you are drawing a graph which says for daily, give me daily sales for the last 2 years. That's still like 700, 800 rows, right? So
Right,
that's
right.
not a lot
Yeah,
of data.
exactly. No, no,
Yeah.
it's not.
Yeah. So what I have, let's get back to the diagram. There are a lot of things which I have assumed, but I'm not totally about. So one is the fact that basically I'm using Spark streaming everywhere. So this table is also going to be produced with Spark streaming. The only thing which needs to be done, this would require, this can be done with Spark streaming, but I think it's easier if this aggregate table is produced with a batch. I'll tell you the reason why. This job should be Spark batch because we are saying the return policy is 30 days, right? So if the return policy is 30 days, we need to read the last 30 days of data and aggregate the data and populate this table. So this specific job would be Spark batch, and it will read the fact table for last 30 days of data. Does that make sense? And this last 30 days is derived by the fact by our return window. So return window would define how many days of the data needs to be refreshed.
Yeah, and then to add to that, since it's not real time statistics, it would be okay for us to run, one batch job every 24 hours.
Yeah. And if we decide that we want lower latency, we can decide to run it, once a day. Doesn't matter. Every
Mhm.
every day, you would go and read the last 30 days worth of data. Now 30, 31 days, I'll not talk about those small times, right? But yeah, approximately that you can decide to do that. What else? We didn't talk about what would make the fact table unique. So let's go there. I never mentioned it. So let's
Can
say
we
what.
can we first go
Mhm.
over exactly what's in the fact sales table? Like,
Yeah, sure.
what do you
Let's do
before we
that.
go into the uniqueness? I guess
Okay. I'm always uniqueness first.
I'm a little tired right now, so
Okay, okay,
uh,
okay. Got it. Okay, cool. So let's see. So basically, people are going to refund, so we should know the amount, right? We probably also need to know the tax, right? So it would have the amount of the product, the transaction amount, the tax amount, maybe what the vendor paid for it, what the customer paid for it, stuff like that could go into the as metrics into the fact
mhm.
table. I think that
Yeah, that's a
should.
good idea. And then, because in the future, you may want to, let's say the vendors are saying, well, we know how many products are sold, but we don't know how much money we made. I sold 1 million keychains. Each one costs 1 cent. And it's still pretty
Yeah,
good. But let's say it's, you get the idea.
yeah. So we could have metrics in this table, which would be like vendor cost, sale cost, sales tax, right? You would want to know the region where the tax, basically you need to know the region where the tax needs to be paid. So maybe we can capture that in the
Mhm,
same table. So maybe tax region. Again, bad
mhm.
column names, come figure out better column names. So these are a few things.
Vendor cost,
Now,
customer cost. So with this wouldn't contain the product ID or any of those things that would be
that
joined
that I
at a
was
different stage.
no that I was going to mention as part of unique key. I was mentioning the
Oh, okay.
metrics first. So what would make this data unique would probably order ID first, the product
Mhm,
ID. If you are dealing with a warehouse or a lake, you can also create surrogate keys. You can assume it's product SK also for simplicity. So we also had vendor ID,
What is SK? I don't remember.
surrogate key. So
Oh,
in
okay.
data warehousing, IDs come from OLTP systems, and in a data warehouse, you maintain it, but you do not rely on it. Okay, so it
I
basically
see.
protects you from whatever things your source team is doing or your application side is doing. So data warehouses
Mhm,
generate their own key to protect its integrity of the data, right?
mhm.
They don't solely rely on vendor ID, customer ID, stuff like that. So the key which a data warehouse or a data lake you can generate is called surrogate key, which is under
I see.
your control. Say
Yeah, so
example, your
there's no collisions, and that some developer starts sending messages to Kafka that says, okay, these are all under the same vendor ID, and they're
yeah,
not.
yeah, something
So,
like that. Actually, I'll give you a simpler example. It's say you start off with a Postgres system, right? And later you realize, oh, this is not like the source system realizes this is not efficient. I am moving to Dynamo or Cosmos, or I may be moving to Postgres Aurora. So what's going to happen
Mhm.
is their ID column might change, right? They
Mhm.
previously they may be producing integers. Maybe now they say, oh, I'm going to produce GUID, right? Or they're going to
Mhm.
produce strings, or they just reset the ID number in the new system, right? Because ID is
Mhm.
also a generated column. So to make sure those things do not impact the data warehouse, which is the single source of truth, in data warehousing, Kimball talked about the concept of surrogate keys. So that's where it's coming from. Makes sense?
Yeah, it makes total sense.
Yeah,
Thanks
it's
for
a long
explaining.
yeah, it's a long concept, but I tried. So the unique key would be order ID, product ID, vendor ID. We obviously also need an order date. Okay, so I think these things together
What if you
would
did order
even
date time to
yeah,
make it
yeah,
even
yeah,
more unique? Because remember
yeah,
earlier we were talking about that and saying, well, what if you bought the same product at the same time? Actually, this
yeah,
wouldn't fix that problem because the order goes in at the same time. Anyways,
yeah,
I don't want to get too crazy about the disaster things that could happen
yeah.
because we want to keep it kind of straightforward.
Yeah, and also order timestamp won't be part of a unique key. Order ID should ideally just handle that. So order timestamp, I'm just moving into metrics, but essentially there would be a
Okay.
column which would be order date timestamp. A few
Mhm.
things. Let's get back. So how many vendors? 10,000. That's fine. Uh, we are storing aggregate tables. You could have 1 million vendors in the aggregate table. You can have 10 million vendors. It would still work. Okay. Data skewness also we are aggregating doesn't matter as such. Uh,
Mhm.
like let's see, retention. So this part is where I mentioned how we should partition the fact table. Let me just mention that. This is my partitioning strategy for the fact table. I said we should partition on a date column. That's the most natural thing to partition on. You should partition on something which is immutable, right? Which can never change. You don't want a record going from one partition to another because some change was made. So order date cannot change after an order is made, right? So that is why we can choose that along with say country, right? And my rough rule of thumb is anytime you have less than 100,000 partitions, you're fine. You don't ever have more than 100,000 partitions. This is giving us
Mhm.
2,000 partitions. This is fine. We already discussed about this. We did discuss about forecasting. Well, but I think you can take this fact table, right? Put like train a machine learning model or train a statistic model, and then put that in the aggregation and actually update the aggregate table. You can also do something fancy, not fancy. You could also, what you can do is do it retroactively. So you can have a machine learning algorithm which reads this table, okay, and populates the forecast and updates the aggregate table async. So you don't want you you if you want you can put that in the same Spark streaming job. You can also put that in two different Spark streaming jobs. Does that make sense? I don't think so.
Mhm.
Go ahead.
Um, yeah, can you go over that one more time? What would the model do? The machine learning model?
So
What
we
would it be
said we
predicting?
we said we wanted some time of forecasting should be available,
Oh,
right?
yeah, of
Like
course. Yeah.
so forecasting, I was saying like you can have a statistic model, right? But you can also have
Mhm.
like a machine learning model. So let me say. So what I was saying is that let's say you have a machine learning model, right? So
Mhm.
what you can do, and in the newer databases it's supported, you can train a machine learning model and put it inside a user-defined function. Like you can have like a SQL user-defined function, which behind the scene calls the machine learning model and gives you back the prediction or the forecast.
Mhm.
Okay, so what I was saying is either you put this UDF inside the Spark streaming job, right? That way it gets populated when the aggregate is happening. That's
Mhm.
one approach. The other is do this async. Have a separate process which calls the machine learning model for its prediction and gets the output. As I'm
Mhm.
speaking out loud, and if I was supposed to maintain this pipeline, I'll put that in a single job. I wouldn't have a separate job run the table, update the table twice. So I would train a separate machine learning model, define
Mhm.
it as a UDF, user defined function, which could be called, get the output and write it into this table while we are writing as another column, which is forecast, right?
Yeah.
So
Thinking
in
about
the
that, so I would think probably the machine learning model might want to use seasonality data. So let's say
uh-huh.
that you sell typically 10 what is it 10 things of wrapping paper per day,
Uh-huh.
and let's say it's December 15th, and you start to sell a lot more of them. So
Mhm.
using the data only from this, you could probably still get that information because of this. Let's say you had multiple years worth of data for a particular vendor, then you can use kind of local and global information. So let's say globally, everyone gets this much more percentage of sales during Christmas, or these particular types of vendors do. But you in particular, you as a vendor, last year and the year before in December, on December 15th, your sales were 20% higher. So you would probably be able to get that information from the data that you're aggregating here, I believe, from the
Yeah.
ag vendor table.
Yeah. Yeah, you can do it that way. The only caveat I can think of, and by the way, I'm not a machine learning expert by any means. I can run a machine learning model for you, but I can't definitely make a good one for you. So when you have new vendors,
I'm just coming
which
up with hypotheticals. I don't really. I'm not
yeah,
prescribing.
yeah. No, I'm trying to tell you a edge case. With the edge case is for brand new vendors. For him, we have no data, right?
Mhm.
But what we can do is that if we rely on the global data, we can basically do what Netflix does, like Netflix like model. If you are a vendor which looks similar to my rest of my vendors, your probably forecast is something like that. Right. So that is where the forecast would be better for new vendors if we rely on the main table, provided our machine learning is that smart of what I'm talking about. Right. Which it
Mhm.
figures out, oh, you are a vendor whose attributes look similar to the rest of the vendors in this category, your probably sales are going to be that. But yeah, this is too fancy, I would say. But yeah, possible, clearly possible.
You know what? Usually forecasting is always a bad idea. So maybe not doing it all. But it's just there because people like it
Yeah.
and they're going to ask for it, even though it's not helpful sometimes.
Okay. Okay.
Everyone loves
Uh,
dashboards. I had some follow-up questions here,
sure,
but
sure.
I can't find them. Back to questions. Let me go back. I'm sorry. Oh, here it is.
And we also need to talk about refunds because I have not mentioned how we're going to handle refunds. But yeah.
Oh, I just was wondering at what point would it be considered refunded. I think once it hits the warehouse, well, I actually don't know. Because there's the intent to refund.
Hmm.
And so do we use that intent and say to the customer, this is how many people refunded something? Maybe I think that would be okay because we're trying to do is understand customer behavior and not really what the end result was. So let's say that people intend to refund something, but they never end up mailing it back. Like that information is not that useful for forecasting. Um,
Yeah, no, I'm not thinking about forecasting. I was just mentioning that to handle refunds per se, essentially a
mhm,
refund would act as an event, and you will use Spark Streaming and actually update our fact tables. So we can do that. Ideally, you want immutable facts which cannot change, right? So, but here we have an example where an order is made, but the order amount changes or a refund is made, and things need to be updated. So that is why we have technically a fact table, but the fact is not mutable. Now you can make a call whether you want to call it a fact or not. But anyway, idea is we are going to have a table which at every point will reflect you the last status of an order. That's what this table will do for you. And if you want to show more details of what exactly happened, then the landing events table would help you with that. If you want something in interim in between, you want another table in between, which will, talk about just because the events table, vendor information, customer information, product and sales. If you just want, what happened in a sale exclusively, you can either decide to filter the events table or put another table in between. Anyway, I'm making the question more complex than it is, but
mhm.
I just want to say to handle refunds, essentially event it will happen as a new event, and that event will go update the fact sales table. And since a new event, Spark Streaming would pick up and update the table. That's all I wanted to say. or repenting
Yeah. And then
funds.
probably that would be used by a different, probably a different team or different person. Because if you're processing returns, you want to act on things within the hour, let's say, or you want to at least respond to the customer and tell them you've gotten their return request.
Hmm.
Or the other case where someone ordered something and you wanted to connect with them to make sure that they're going to get their package delivered on time, things like that.
I would say no. I would say that's not a data warehousing use case. That's
Mhm.
a transactional use case. So those things should be handled by the OLTP system and not
Mhm.
actually the data warehouse.
I see. So let's say that you wanted to connect some type of application to where it would, and I'm changing I'm not changing anything, but I'm adding things. So let's say that
Okay.
we built this, and then the vendors have their dashboard and they're really happy with it, but
Hmm.
they're saying, well, now I know that I have these returns, but for some reason I want to know when people are returning things. Is it in the morning? Are people returning things at the end of the month? Well, actually, you would get that from the dashboard. I'm trying to come up with a follow up, and I'm not succeeding. Uh, well, I'm kind of trying to come up with a situation where you would need something more real time. And I
Okay.
guess what would happen here is that you would basically just subscribe to the Kafka queue and then deal with things that way and send that
Yeah.
to
So
like a messaging platform or something and answer. Yeah. So that's,
So, so if let's say this refund use case, what you can do is that you can have like a job, right? And this could be like a real-time job. And let's
mhm,
say your refund use case, you can have specifically subscription to these refund events. And
mhm,
rather than triggering using, once a day kind of a trigger, what you will do is you'll do real-time streaming. So that's what you will do. And that way you can do whatever analysis on this table, and realistically you can get data from Kafka from one delta table to another in even 30 seconds. So it's possible very easily.
yeah. So, and this is better than going directly off Kafka because if you're reading
Correct,
directly
because
off
Kafka is
Kafka,
not accessible.
right, and
Kafka is
it's not
not
going to be
accessible
evergreen,
for, yeah, it's and also you're going to lose the data after 14 days. So that is why
right?
this would be
Yeah,
slightly better.
yeah,
Not like significantly
exactly.
better, slightly is understatement.
Let's see. Well, I think I went through all of my follow-ups. Actually, I didn't even ask them, but they were all answered, I believe. Different events. So we went over the different events, processing returns. Can we talk about one thing is like in the case, let's say the Spark job here that goes
Mhm.
from LND events to all these dimension tables. Let's say that job breaks for 24 hours, or let's say you're on vacation and you're not going to be back for 2 days and
Mhm.
no one knows how to fix it, and you get back
Mhm.
and now you have to fix it. And then so once you go, and let's say you have a cluster of a certain size, let's say it's 1,000 machines, maybe in this case it might be much less than that, but let's say you're running this and you have a certain number of machines that you allocate for dealing with the current amount of traffic that everyone's seeing. And let's say that 48 hours of time, that cluster that you provisioned, it's able to handle the current stream of events that are happening in real time, but it's not really able to go back and reprocess everything at the same time that it's handling current events. So is there any type of what would you do to replay kind of those events that were missed?
So I'll break the question into parts. So one is event cannot be missed, okay, unless Kafka forgets it. Okay, so if in our
Mhm.
case when we said Kafka has policy of 14 days, even if the job fails for 10 days, 13 days doesn't matter. As long as it runs on the 14th day and the message is available in Kafka, it will go get the message from Kafka and process it. So
Mhm.
Spark Streaming has something called, all of streamings usually have a checkpoint, and checkpoint remembers an offset. The offset is the last, it's, you can think it as the last message ID is processed. So it remembers that
Mhm.
in the checkpoint. So as long as the message is in Kafka, no matter how many days your job fails, whenever it restarts, it will never miss a message. Okay.
So it's not the job that's taking things from Kafka to the PRD events. Is that LND
LND.
events? So let's say
Uh-huh.
everything is in LED events and it's fine. We didn't lose anything from that table, so it's all there. But
Correct.
we also weren't able to calculate the rollups. We don't have up to
Uh-huh.
date data, and the vendors and customer were like 2 days behind. So and there's a cluster, this cluster that we're running. we want to be able to
This
go
thing
back.
cluster is not scaling.
Yeah. So
The
let's say
job
that cluster is not scaling, and because you have to go back and
read now much more
re
data than you previously read, right?
yeah, right. Because like we're
Yeah,
only
yeah,
able to handle what we're dealing with currently, but
correct.
calculating 2 days worth of data for some reason is going to be I can't handle it or something. Maybe.
Okay, yeah. So the way to handle it is that in Spark Streaming, there is a parameter called max bytes per trigger. So
Mm-hmm.
it defines like a limit on how many bytes it's going to process per each run. So you can play with that parameter and set it to a level where which you know it scales. Say you set it at 10 GB, 100 GB, whatever you feel. And what your application is going to do is that it's going to run the Spark streaming job multiple times with this trigger available now kind of thing. So it basically figures out what's the latest offset in Delta table, and it knows the backlog, and the max bytes per trigger controls how much data it's processing per each execution. So say you have 1 terabyte of data and you set max bytes per trigger as 100 gigabyte, then it's going to run itself 10 times to process the 1 terabyte of data. So that way you can still operate on the small cluster. You will just
Mm-hmm.
have to do multiple runs, and it's actually a practice. It's a best practice to actually set that limit to something. Or if you expect too much data to come, you should have like some limit on how much you are asking to read. Another reason you want to do it
Oh, that's
is that,
interesting.
yeah, reason what can happen is that if you're directly connected to Kafka and if you ask for a lot of offsets, like a lot of messages at once,
Mm-hmm.
there's actually a lot of wait time, because now everything is the Spark job is going to be stalled waiting on Kafka to send all the messages. So
Mm-hmm.
that's another reason, because you'll be paying for the compute while all the time you are just waiting on messaging to arrive. So that is why you want to set some kind of a reasonable limit on how many messages you want to process in each Spark streaming iteration.
Yeah, that's very smart. So that's a lot better. It seems a lot better than growing the cluster to arbitrarily large to handle
Correct.
processing all of these events for the last 2 days in 5 minutes when actually you don't need it for 24 hours anyways.
Yeah.
So it makes more sense to just kind of, okay, set that limit ahead of time and it would just would it handle itself all and you wouldn't have to do anything? It's not a manual process.
No, you can just set it as a parameter, and then if you use this parameter called available now,
Mm-hmm.
this is like specific to Spark streaming. It will figure out how many iterations it needs to do. Yeah,
Mm-hmm.
into that.
Would you actually have to set? So let's say the streaming job is running and it's currently processing events that are coming in kind of real time. Would you have to go in and say that you want to go back 2 days and from this date you
You
want to
you, you
reprocess?
can you
Mm-hmm.
can. One question realistically, I think, why do you want to do that? Because the message is processed. That being said, even if you want to do that, what you need to do is ideally create a new checkpoint. So streaming relies on a checkpoint. And when you
Mm-hmm.
start the new Spark, you basically in your Spark streaming pipeline, you can specify what offset you want to consume this data from. So
I see.
um, and your landing events table, usually I would say if you're getting messages from Kafka, you also store the metadata which you get from Kafka. So you would have an idea what's the last
Of
offset
the
you
offset.
consume.
I see. Yeah,
Yeah,
I was thinking about that. Well, let's say the Spark thing, I was thinking in my head, okay, Spark failed and that job is broken. So now it would have to know where do I start off again. So
yeah,
that's nice to know that there would be an offset there and it would just kind of start where it was before. And that way, instead of getting just today's how many you sold or how many returns are there, there wouldn't be this gap. You would actually start to see
correct.
2 days
It will,
before. Yeah.
yeah. So it would not miss a message. So it's like multiple levels of robustness. The one is it
Mm-hmm.
won't even have first a checkpoint. Checkpoint would remember. Checkpoint is a folder, like a file. It's actually a folder which has multiple files, but it would
Mm-hmm.
remember what offset it's consumed. Okay, let's assume you delete the checkpoint, right? You somehow
Mm-hmm.
decide to delete it. You can still go back to your LND events table and do a max and figure out what's the last offset you consume, and then start your Spark streaming application using that offset.
Mm.
Now, if you say I'm going
Okay.
to delete the events table also, that I can't handle.
So don't delete the events table. I got it. Don't delete database. Okay.
Yeah,
Well, I think you killed this problem. I really like this question because it's a realistic use case, and it's It's done over and over in many different ways, and you can use the same type of pipeline, I believe, for many different use cases. And this is actually, I feel like, something that would be worked on. It's not really a contrived question. I think it's very realistic. And that's why I like the question.
If someone is looking for a perfect dimension model, they should go read Ralph Kimball's book, The ETL Data Warehouse Toolkit. I have no intention to replicate it or meet it. I've just tried to use the best practices I've learned over the years and from the book. But yeah, don't try to compare it with the best there. If you're looking for the best data warehouse star schema, ETL Data Warehouse Toolkit by Ralph Kimball is the book for you.
Okay, excellent. Okay, thank you everyone for watching. And we have more data science questions and data entering questions on Interview Query. If you like coaching, Interview Query does coaching for all different types of roles and levels. And please comment, like, and subscribe to the channel.